Hi everyone, my name is Carla Sandoval and today I will be presenting about investment savings and loan terms in Excel. So to start off, I would like to introduce Excel first to those who have not used it or are not very familiar to it. Excel is just a spreadsheet program that is used to record and analyze numerical data. Um, a spreadsheet is a collection of columns and rows that form a table. There's usually alphabetical letters that are assigned to columns, and there's numbers that are assigned to the rows. The point where a column and a row meet is called a cell, and a cell can be addressed by naming the column and the row number. So as we see here, you can see that the columns are in alphabetical order and the rows are in numerical um, order. And here the cell highlighted is A1. This is what a regular spreadsheet looks like without any kind of data input into it, and obviously once you have that, you can go in there and make it personalize it and make it your own. So a little bit about Excel functions. There are a variety of functions that one can do in Excel. A function is a predefined formula that performs calculations using specific values in a particular order. Some of the most common functions that you can find in Excel and that are very easy to work with is the sum, average, counts, and maximum and minimum value. These are pretty easy to use and are very easy to work with. So here we can see how a sum function is used in the Excel spreadsheet. The sum function is able to add all the numbers in a range of cells and return the result. Here you can see that we're adding 10 plus 34 plus 35 plus 17 plus 2, and then that comes up to be the 98. How you would do this is by putting the equal sign, writing down sum, parentheses, then you would choose each of the cell like it is shown in the picture on the left. And then once you're done choosing the last number, close parentheses, click enter, and that's how your final answer is given. So, moving a little bit deeper into the functions that are related to investments and savings, and moving away from those common functions that we previously talked about, the functions that we will be focusing on right now are the future value function, the present value function, the rate function, and the number of periods function. Below each of these functions, you can see that there is an equation that you will use when inputting your information into the spreadsheet so that it can then give you your final calculation. For example, with the future value function, how you would do this in the Excel spreadsheet is by first putting the equal signs, then following the FV, which stands for future value. Then you would put parentheses, you would put down your rate, the NPER, which is the number of periods, the PMT, which is the payments, and the PV, which is the present value. You will then close parentheses, click enter, and Excel will automatically give you your calculation and the answer. This same process is basically the same for all of the other functions, except they each do change a little bit depending on the information you have available and what you are trying to calculate. If this does not make too much sense right now, please don't start to worry. We will be getting into much more depth with each of these equations in future slides. So moving into what compound interest is, it is the interest calculated in the initial principal, which also includes all of the accumulated interest from previous periods on a deposit or a loan. This is mostly used in savings accounts and loans. Um, in savings accounts, it is used by depositors to keep money at their banks, and for loans, it is used by banks to be able to give you a loan. So, some important vocabulary related to investments and savings and the functions that we will be working with. First is the interest rate, which is the portion of a loan that is changed as interest to borrower. This is typically expressed as an annual percentage of the loan outstanding. Also, the number of months or years is the total number of payment periods to pay off a loan. The payments are the payment amounts that are due at the end of each period. That is either the end of each month or the end of each year, depending on your situation. The current value is the present value that a series of future payment is worth right now. This is if you have $10 in your bank account or 100, this is what you will have is what you have now and are planning to invest or what you're planning on using to pay off a loan. And lastly, the anticipated amount is the amount of money one wants to have owed or expected at the end of the month or year. So, moving a little deeper into the future value function, what this function does is that it calculates the future value of an investment. An example we have here to explain this a little better is that Maria has $10 as of right now and has decided to invest this amount into her savings account with a 9% interest rate. After leaving these $10 in her savings account for 30 years, she will then have $132 with 68 cents total in her savings account. To the pictures to the right, you see how the formula is being broken down into parts. We see that the interest rate is 9%, that the number of years is 30, and that the current value is $10. You then put this into the FV function, how it is shown in the second picture, which is by putting the equal sign, the FV, and then following each of the cells in the correct order. You close parentheses, click enter, and it will give you the total of $132 with 68 cents. The reason that we do not input anything for the payment cell is because we are not making periodic payments for any of these next functions that we will be talking about. But this is built into the Excel formula, so we have it indicated here, but just once again, we will not be using it for our examples. So now moving into the present value function, what this function is able to do is calculate the present value of a loan or an investment. An example that uses this function in Excel, it says here that Carlos would like to buy a car for $5,000. With a 7% interest rate, he needs to invest today $3,331 with 71 cents in order to buy a car in 6 years. Here we see that the interest rate, once again, is 7%, the number of years is 6, and the anticipated amount is $5,000. You input this into the PV function, just like you see in the second pictures, by selecting each of the cells. And then you click enter and it'll give you the amount that he needs to have today, which is the $3,331 with 71 cents, in order to invest them and be able to buy a $5,000 car in 6 years. Now moving into the rate function. This function is able to calculate the interest rate charged on a loan or the rate of return needed to reach a specified amount on a investment over a given period. An example of this is that Ryan has a total of $1,000 in his savings account and hopes that in 50 years he will have 150,000. The total interest rate per year should be 11% in order to achieve his goals. Once again, we see that the number of years is 50, the current value is $1,000. It's the amount that he has right now, and he hopes to have 150,000 in the future. You input this all into the rate function, which goes as the equals rate, and then the number of years, the current value, and the anticipated amount. And once you do that, it comes out to be the 11%. So the number of periods function is able to calculate the number of periods that are required to pay off a loan or reach an investment goal through regular periodic payments and at a fixed interest rate. An example that we could use to show how the NPER function is being used says here that Amanda has a value of $300 and wishes to increase her amount to $2,000 with a 9% interest rate. In order to do so, she will need to wait a total of 22 years to have those $2,000. Here in the pictures, we can see how this is being broken down. We know that the interest rate is 9%, that her current value, meaning the value she has as of right now, is just $300, and she wishes to have those $2,000. In order to figure out how many years it will take her to reach that amount, you will then use the NPER function. And in the second picture, you see how the NPER function is being used. It's the equals NPER. You click on each of the cells, you close parentheses, click enter, and it will then give you the answer of 22 years in total that she will need to wait in order to have those $2,000. So now we will be moving into amortization and loan terms. First of all, amortization is the process of paying off debt with regular payments made over time. These payments can be tracked through what is called an amortization schedule, which is a table that provides the details of the periodic payments for an amortization loan or a loan term. And lastly, we know that a loan term is the length of time it will take to pay off that loan. Some important vocabulary that we need to pay attention to before we get started is first, beginning balance refers to the total amount of money owed at the present moment. Total payment is the amount of money that is being paid each year or month. The interest paid is the total amount of money that is paid in interest. The principal paid is the total amount of money that is paid towards the loan. And lastly, the ending balance is the new total amount of money that is still owed after the payment. So now taking a look at an example for an amortization, or in other words, a loan term. Here we have that Stacy is looking to buy a brand new car with a loan of $17,000 with a 4% annual interest rate and a 4-year duration with monthly payments. She will need to make a periodic payment of $383 with 84 cents to pay off her loan. And by the end of her payment period, she will pay a total of $1,424 with 51 cents in just interest. So to the right, we see pictures of how the payment function is being broken down and how it is being used in an Excel worksheet. Here we see that the annual interest rate is 4%, but we need, since it will be monthly payments, we need to have a value for the monthly interest rate. And how you would do this is just by dividing the annual interest rate by 12, which indicates the 12 months. So here we would do 4% divided by 12, which will then give us the 0.33%. The same thing goes with the years. It is 4 years, but once again, we need monthly. So we would do 4 times 12 months, which gives us a total of 48 months for the number of periods. And the present value is 17,000. You input this into the payment function like you see in the second picture, and you click enter, and that's when the $383 with 84 cents comes up to be the monthly payment that Stacy will be making. So in this slide, we have an example of what an amortization schedule looks like. This example also relates back to the example that we were talking in the previous slide. And here we can see more clearly where the amount of interest paid or principal paid is going towards and how much of that money is being paid. So first of all, an amortization table is a schedule that lists each monthly loan payment as well as how much of each payment goes to interest and how much to the principal. Every amortization table contains the same kind of information. This includes the total payments, which are the required monthly payments that are listed individually by month for the length of the term. And in this case, it's the 48 months. An amortization schedule also includes the principal paid, which is the remainder of the payments that goes towards paying off your debt after you apply the interest charges. Also, we can see the interest paid, which is the amount of money that is being paid in pure interest. And lastly, we see the ending balance after you pay or you make your payment. So here we can see once again how the total payment is being calculated. You do this by using the total payment function in Excel, like I mentioned before, and which is the equals payments parentheses, then you put in the rate, the NPER, which is the number of periods, the PV for present value, and the FV for future value. You close parentheses, click enter, and it gives you your total amount. This amount will always remain the same for every single month. It does not change throughout your loan payment period. Next, we move on to calculating the interest paid in an amortization table. Here we have a picture of what it might look like in your Excel spreadsheet if you were to do this for your own loan term. So to calculate interest paid, you have to multiply the monthly interest rate by the beginning balance. In this example, we see that how you would do this is by multiplying the monthly interest rate of 0.33% times the $17,000 that you had at the beginning. Once you do this, it comes out to be a $56.67 that you are paying in total for interest only. How you would calculate principal paid is by subtracting the interest paid from the total payment. Here we see that this is the $383.84 minus the $56.67 that we calculated for the interest paid. Once you subtract these two numbers, we see that the total is $327.18 that is going towards actually paying off your debt, which is the principal paid. So after calculating the principal paid, we can then go ahead and calculate the ending balance. And we do this by subtracting the principal paid from the beginning balance. So in this example, we know that Stacy started off with a $17,000 loan. And after making her first payment, she paid a total of $327.18 towards her principal. You go ahead and subtract these two numbers and you get $16,672.82 as the ending balance after that first payment. This same amount then goes back to the beginning balance for the second month, and you go ahead and do all of these calculations once again until you get to the 48-month period, and that is when it should equal out to be zero and Stacy is done paying off her loan. So I know that there was a lot of information in this presentation, but if there are two things that you should take away from this whole video is first off that compound interest is the interest calculated in the initial principal, which also includes all of the accumulated interest from previous periods on a deposit or a loan. And once again, this is most commonly used in investments or in savings. And also, we know that amortization is the process of paying off debt with regular payments over time. This includes loan terms and the total interest paid that we calculated in an amortization schedule. Lastly, this is a very powerful thing to know and know how to work with because compound interest is able to turn a small amount of money into hundreds of and hundreds more. When buying a car or a house, this is a way to know how much money you are solely paying in interest, and overall, it's just a better way to budget your money and know where your money is going towards. If you have any questions, please feel free to contact us. Here you can see our phone and email address in which you can call us or email us any of your questions. Thank you very much for listening.